Hi guys, welcome to the How to Crack the Java interview. Today we'll discuss some of the algorithm question. Actually, that is the algorithm question asked by one of the interviewer in JP Morgan. First question is what is the difference between algorithm and program? What is the difference between algorithm and program? Actually, algorithm is nothing but a design. Algorithm is nothing but a design and the program is the implementation of design. Program is the implementation of design is called the program. Actually, who will give the design? Actually, those are having domain knowledge, they will give the design. First they will give the design. Based on the design only, programmer will do the program. Okay, programmer also have the domain knowledge, but specific person is there who has more domain knowledge. He will give the design. Based on that, programmer will start the program. Actually, algorithm does not depend upon any language. Algorithm does not depend upon any language. Can any language we can write the algorithm, but program is depend upon the programming language. Program is depend upon the programming language like C++, Java. These are the programming language. We'll discuss next question. What is the next question is the quick shot algorithm. What is the quick shot algorithm? Quick shot algorithm, just example, I have a array. I need to sort the array by using the quick sort algorithm. First, just example, that is one array 10, 80, 90, 30, 40. These are the element is there. These are the element is there. Then how to find how to find the which element in the sorted position? Which element is the sorted position? Which element is the sorted position? Actually, here see 10. 10 is the sorted position, because the element in the sorted position, element is the sorted position because all the element before that should be smaller than that element. All the element after that element should be greater than that element. See, all the element after 10 is greater than 10. That's why 10 is sorted position. 10 is in 10 is in 10 is in sorted position. Sorted position. Okay. Well, quickshot is working on that idea only. Quickshot is working on that idea only. Okay, quickshot is working on the idea that all the element, an element, not all the, an element in sorted position, the all the left side should be smaller than that. All the element right side should be greater than that. Okay, and quickshot actually follow the divide and conquer strategy. And means it is split the problem into sub problem. It is split, just example, we are working on array. It is split the array into sub array. It is split the problem into sub problem and those two solve those two sub problems. Let's see how it is working. Quickshot will go, to paint. We have an array like content 10, 16, 8, 12, 13, 6, 3, 9, like this element. Actually, i'll I need to sort that array. First, I need to make some initial setup. I need some initial setup. Okay, then I'll show how it is working. Okay, first 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 element is considered as lower. Just example, first element, that 10 is considered as low, and maximum element, that is infinity. I can that is the maximum in limit, maximum integer. I can put as high, that is low. 10 is in low, that infinity is the high. Then 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 just example, uh, that I consider a pivot element. First, I consider the let's select a first select a pivot element. I'll select a pivot element of the array. Just I select a pivot element as 10 pivot pivot as 10, that is my pivot element. Then first I want to find the sorted position. First I want to find the sorted position of the 10, sorted position of the pivot element and sorted position of a 10, like that. Then while we while we should come when we should come 10 should come at the position. When it should come, 10 should be in the position, all the elements should be all the smaller elements should be in the left side of the 10, and all the greater elements should be right side of the 10. Then if I'll find any greater element in the if I'll find any greater element in the left side, then I will send to the right side. If I'll find any greater element in this position in the left, then I'll send to the right side. If I'll get any smaller element in the right side, then I'll send to the left side. Okay, we'll take we'll take I I'll take I int I and j. I will starting from the pivot. First I will start from the pivot, like I will start from the pivot I equal to pivot. Then j will start from the infinity. J will start from the infinity. First j will start from the greatest element infinity. Okay, okay, okay. Then I will be search the then I will plus plus, then I'll start I plus plus, then I will search the element greater than pivot. I will search the if I will find from here I is pivot, then I plus plus, I will find the I will search the element greater than pivot, and j will also search the element j minus minus, j will search the element smaller than pivot. Then so that they can exchange the number. Okay, I at most stop at infinity, j at most stop at a pivot. Okay, now we'll show how the how the procedure is working, the partitioning is working, that is called partitioning. Okay, first I is in pivot, then I plus plus air of pivot is 10, then in I will do the next position, I is in here. I plus plus means I'll come to I first I was the pivot, it was 10, then I plus plus. I'll go to the next position, that is 16. 16 I is here. Then AR of I is greater than AR of I is 16 is greater than pivot. Yes. Then J will come to J minus minus, J minus minus, J minus minus, J will come to that position, J will come to that position. J is here now. J is here. AR of J, AR of J is less than pivot. Yes. Then if AR of I greater than pivot and AR of J less than pivot, then they will be swap. They will be swap with each other. They will be swap with each other. Then 16 will be swap with 5. 16 will swap with 5. 16 will swap with 5. Like this. 16 will swap with 5. Like this. 16 will swap with 5. Okay. How they swap? Then 16 will swap with 5. Then here 5 will come to here, that position, and 16 will come to here. Okay, 5 will come to here, 5, then 16 will come to here, 16 will come to here. Okay, next time I will be I plus plus, then I plus plus, then I will be here. I will be I will be here in that position. I, then AR of I is 8. 8 is G. 8 is G greater than 10? No. Then I plus plus. Again I'll come to the next position. I is in that position. I is in that position. I. Then AR of I is greater than 10. Yes, 12 is greater than 10. Then J plus plus. Go to the J plus plus. J, now J is in that position. Ninth will come to 9. J, J is here. J is here. That is the J now. J is here now. Okay. Then AR of J is less than 10. Yes, less than pivot. Then they will swap. Then 12 and 9 will swap each other. 12 and 9 will swap each other. 12 and 9 will swap each other. Okay. 12 and 9 will swap each other. Then here 9 will come to here. 9 will come to here. Then 12 will come to there. 12 will come to ninth position. Yeah, 12 will come to here. Then I plus plus. Then I will be go to the next position. Then I will be here in 13. AR of I is equal to 13. 13 is greater than 10. Yes, 13 is greater than 10. Then J minus minus, J minus minus, J is come to that position. AR of a J is 3. AR of a J is less than 10, less than pivot. Yes. Then 3 less than 10. Then 13 and 3 will swap. 13 and 3 will be swap. 13 and 3 will be swap. 13 and 3 will be swap each other. Okay. 13 will be swap like this. Okay. 13 will be swapped by 3. Okay, here 13 will come to here. 13 will come to here. 13. Okay. Then I plus plus and J minus minus. I plus plus J minus minus. Then I'll move to that position. I will be here and J will be there. I will be here and J also there. AR of I is greater than 10. No. Then I'll move to the next position again I will move to the next position again, then I will be here, then I will be here, then j minus minus j will come to j will come to j will come to that position, sixth position, then will come to here j. Now I cross the j, I cross the j means I cross the j, I cross the j means then if I cross the j, then the pivot element and the jth element, pivot element and jth element will swap with each other, will swap with each other. If they will swap each other, they will swap each other if 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 I if a if I greater than j, if I greater than j, then swap of a pivot with a of a of j, a of j. Okay, that is the then 10 will go to that position, 6 will come to the pivot position. Here 6 will be here, 6 will be here, then 10 will go to the there, 10 will come to that position, 10. Then 10 is the shuttered position now, 10 is the shuttered position now, then then split split into two partition, then split into two partition from 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 6 to 3 is partition 1, then another one is 3 to 6, that is the partition 2, that is the partition 2, partition 1, that is the partition 2, the partition 1, partition 1, second one is the partition 2. Okay, then how programmatically it is working, we'll see that. Okay, just example that okay, first partition, first partition at TITION partition of will pass low comma high as argument, then we'll, we'll get the first will get the pivot element, pivot equal to a of low, a means array of low, then I equal to low, then j equal to high, that is programmatically. Whatever we will explain here in diametrically, then It is programmatically. Then then do do of do I plus plus I first I plus plus I is the pivot element, then I plus plus while 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 a of a of I a of I less than equal to pivot. That is the condition. Pivot. Then do while once again j minus minus while a of a of j greater than greater than equal to greater than equal to if j is greater than pivot. These are the two conditions to execute that the get the partition. Okay. Then third one, if I cross j means I greater than equal to j, then I greater than equal to j, then swap. If I greater than equal to j, if if I I greater than j greater than I, then swap of AR of A of I comma A of j A of j. Okay. Then that is okay. Then when when I when I cross the j, then it will stop. When I is greater than j, then it will stop. It will swap AR of low with AR of low means AR of low with then 6 swap with 10. We'll do that scenario. If if I less than j, then I less than j, then continue. If if I is greater than, then then you can write that in here. Swap. Okay, that is okay. Uh, then that condition will not work. Then we'll swap of A of low with A of low with A of j, A of j, then return j, return j. That is the partition method. That is the partition method. Okay. Then how quicksort program will work? Then quicksort will call like this. Quicksort of first we'll go to that. Okay. How quicksort will work? That first will get the partition. Based on the partition, quicksort will be div- divide the partition and solve the problem. Solve the problem. Then quicksort, sort, quicksort of low comma high, then till if low greater than high, less than high, then then j equal to partition of low comma high, high, then it will call the recursive call quicksort quicksort of low comma j, then quicksort of j plus 1 comma high. Yes. Okay. Okay. That is the partitioning. It will call the partition like that. Okay. Control Z. Okay. That is the quicksort algorithm. It will sort like this. Okay. Go to the slide. Yeah. Then we'll discuss next algorithm next video. Thank you.